will ask questions on slido.com/webup, and then you can also ask the audience if they have any other questions. So, Stefan, your time. Thank you.
Hello, people. Thank you. First off, I would like to thank the whole WebUP community and Dana here for organizing this meetup. It's been a long time, for me at least, since COVID basically started, so this is the first meetup after 2 years that I'm having. So yeah, today my topic will be basically building native add-on modules with Node.js and node-gyp. This node-gyp, they're just a kind of like trademark thingy. It's mainly like a native API for Node. So first off, to start, maybe to tell something. I don't know why the presentation. Okay, sorry. To tell something about myself, I'm a senior software engineer at AppLearn. I've been previously part of many successful startups, some in Slovakia and some from where I originally come from, and I originally come from Serbia. I've been living in Bratislava, Slovakia for past 5 years. And for past 2 years, I've been working as a part of a core team engineer, senior software engineer at AppLearn. And so far, I think I've been doing my best to stay on the bleeding edge when it comes to technologies. So yeah, that's me. Now, a bit more about AppLearn. So AppLearn is digital adoption platform. It's originally a UK company coming from Manchester, and it's a company that acquired a local startup called Yeself. Yeself is a startup from Bratislava, made by 2 Slovak guys. And in January 2021, they finished the acquisition process, and basically AppLearn, which was dealing with the same thing that Yeself was dealing with, acquired Yeself as a company. So we are now one singular entity working in digital adoption space. And kind of, if you're asking yourself what is actually digital adoption space, digital adoption is basically kind of like software as a service that's like mostly or like in 99% business to business. Basically, our customers are big enterprises that pay for our platform in order to have like tutorials and guides and to basically make digital adoption of web apps easier for their employees. What it means basically in simple terms, let me move to the next slide. We have Chrome extension or a small script that we inject into your page, or if you're using a Chrome extension using some of the policies, we overlay your page with some guides and tutorials. This is very useful for a lot of companies to basically onboard their workforce, but also during their day-to-day. And there, as I said, like these 2 kind of ways how we approach that problem. Of course, this particular industry is really big. It's of course going even further than just creating small bubbles that pop up that are similar to like old school Windows Clippy or something like that. It's going much further by integrating also machine learning algorithms for basically tracking the user data and seeing, like, for example, if they are confused following a particular guide during their onboarding on a web page. And this particular industry is, as of 2020, worth 5 billion. And here I put 5 kind of logos that I was allowed to put that are part of our customer base. But they're like even bigger names that for now I cannot reveal, but I assume we will soon have that announcement. So basically AppLearn for now is kind of a 3rd best platform in this digital adoption space. There are like 2 more platforms that are in front of us. One is like WalkMe and the other is WalkFix. And they're even way bigger in size. We have like 30 something engineers, and these other competitors to us are having like 500 plus. So they're kind of covering most of this $5 billion market, especially by also covering US mainly. We are also concentrating on EU. So mainly like we deal with like concrete problems that customer have. Like we created an abstract enough solution that works for most of customers, but there are sometimes really like complicated requests coming our side. And usually these contracts used to be or are usually really big, so we need to address like specific customer problems. And one such problem was a year and a half ago, or maybe even at this point nearly 2 years ago, one customer approached us and told us like, yeah, you have a cool solution and it works for web apps, but we kind of want to have seamless integration with also like native apps running on desktop. So basically, what they requested from us was like to have some kind of a solution that will integrate these like basically pop-ups and bubbles and that point to particular elements within or UI elements within the native, for example, AppLearn app, and like, yeah, make it work. And for a long time we were thinking how to even make that, because we are solely web-based. We are basically kind of, when you look from the top-down view, really a simple app, having like a lot of microservices here and there on the back end, and having a kind of a front-end monolith that's dealing with all of our kind of resources that we need. So it was kind of a tricky thing, and especially because back then we were only YesSelf, and YesSelf had like 10 engineers, maybe less, and it was like, but we cannot invest now in like more resources, like people coming and developing some kind of a crazy desktop solution in order to have this. So we were kind of like, how to do that? So we realized, as I mentioned before, that we have like this whole AppLearn, as you can like abstractly think about it, like web app there, and it's probably going to communicate with WebSocket with some kind of AppLearn process, because like we already know Node.js or JavaScript, TypeScript, whatever. So like let's use AppLearn, right? It can run on desktop, and then somehow integrate with this whole AppLearn app. And this specific customer wanted MS Teams, because like it's used in like 90% of these enterprise companies and banking systems or whatnot. So we were kind of like, okay, so AppLearn can run on the desktop, you can run JavaScript there, but like, how do we locate these elements that are especially coming from, for example, a call window? And if you want to like guide your employee how to do a call within MS Teams, we somehow need a smart solution there. So we realized, okay, we don't need to just have one AppLearn process. We can have one AppLearn process like kind of running in the background, spying on the things, and the other one actually, which will be the foreground process, and spawning the windows on the positions where we want them to. And it was all perfect, but then there was one big black box, but I call it here blue, that was like, but how do we solve that part of like actually finding the element that's running on your, for example, Windows operating system, and then actually positioning this window, this kind of guide, a tooltip, let's say, that we wanted to do. So, meet Mark Sokolowski, or Fotix. This is a 26-year-old hacker. He's originally from Ukraine, and he is a famous developer behind the Raccoon Stealer malware. Basically, he earned tons of money by literally injecting something running in the background of people's computers, which is a malware, and doing something smart in order to get their kind of secrets when it comes to crypto money or cryptocurrencies. And then he would like usually sell this data for like 200 euros a month. Long story short, particular company did kind of research of this Raccoon Stealer and analysis of like how this actually works. And in the document, in the kind of paper they published, there was a really interesting part here in the collection part, which was like he was screen capturing in the background all the time. And I was like, huh, okay. I mean, Mark also got caught like during, I think, this summer, but it took them really long to find him. they actually find him because of the war. But the thing was like, how did he like screen capture this whole thing? And it was quite easy. Like when we started researching, we saw that like there's a really good thing, especially on Windows platforms, that can like locate windows, take screenshots, and all of this comes for free without any need of user permissions. And this thing is called basically Windows Automation API. It's basically a thing that comes with every Windows XP onwards operating system, and it's been updated 2 times since the release of Windows XP, and it's basically an API that you can use using probably C++ or C#, and basically there you have like exposed methods, for example, like of giving title names of windows, or screenshotting the whole screen, or taking a screen for particular window, etc., etc., etc. So we were like, okay, cool. We have kind of a partial solution now that we can write probably in C++ or C#, which is fine, but how do we maintain this? Like, we don't have like particularly like versed C++ engineers in our team, nor we kind of don't want to invest money into like hiring suddenly C++ engineer that will maintain part of the product that's only for this customer. So where's the common ground that we can like, what can we do here? Yeah, this is basically like what I wanted. So this is like, for example, one instance of a particular tooltip popping up, if you see here, like log in and out of the response group, that highlights particular element within Windows, Microsoft Teams, sorry. So there we were kind of clear, okay, this is running currently in the web, and it was like, okay, we can do that, but yeah, how to bring that to the native application of Microsoft Teams, and especially like how can they communicate? So for example, if I'm currently in web screen, in web browser, I can see the same pop-up here, the same tooltip, and I want to see the same thing when I open MS Teams, the AppLearn application, just like changed, instead of seeing it in browser to see it in the AppLearn app. And we realized, okay, yeah, definitely we can probably utilize exactly this tool for searching for the correct screen where we want to render this bubble. And as I said before, it was only like the only options were like either C++ or C#, and this is kind of top-level look of like which of these automation methods, or like how this automation API is basically split. And there are like, as you can see, like control types, the general like UI automation client, and then also like automation element, which is something that's interesting to us, right? If we want specific buttons, etc., etc., etc. We were kind of lucky here that we realized that even AppLearn apps, they still are essentially kind of like containing browser there, but initially we were like, sure, maybe we can find out to hack inside AppLearn, and we did that, but I will put that as a black box for this talk, and that might be some further talk. But the problem was, what will happen when AppLearn spawns native-like windows? And these native-like windows that are not actually browser windows was every single pop-up that you see in Microsoft Teams. That includes calls, invites, specific notifications. If you have plugins that are opened within the new window, once you click something in Microsoft Teams, all of these were kind of a specific apps that you cannot hook into, even if you have like full backdoor access to Microsoft Teams. So for that solution, we kind of went through this kind of approach. Let's do it cognitively. Let's take a screenshot and like somehow do the thresholding of the screenshot, and then search like, okay, this is probably a rectangle, and this is probably the open screen. Okay, position this button. And it was like, no, that's super slow. You need to do it kind of real time because like if user would wait like more than 2 seconds for some bubble to show up and like point to the button, it'll be useless software. So we realized that like probably the only way is like to really utilize the UI automation Windows API, because it can hook into those elements because they are exposed to Windows as operating system. And there comes node-gyp or n-API. Basically, this is a tool that allows us to write a C code, wrap it in some kind of a C++ wrapper, create a dynamically shared library that is native to Node.js ecosystem. And it was like, well, this is perfect. We'll basically write this code once, concentrate on writing it correctly, and just create this wrapper, and that's all. From now on, we just need to build it, and that's all. Sure, if we want to expand it, we will need to change, expand our API that we built on top of the Windows UI automation API. We will need to change some methods, but we realized if we have if we kind of try to map it as nearly as possible as one-to-one as the API is, we solve the problem. Because Windows API doesn't change much. It changes only when the new version of the Windows gets released, and that's not that common, and still it has a good kind of fallback mechanisms. For example, if you don't update your methods. So when we started looking in the N API, now it changed name to Node API maybe like half a year ago, but it used to go by name N API. It was basically kind of like really kind of dirty. It was like this is how it looked like to just wrap, I think, one method, and it was like, it looks like C++ code, but it's having a lot of these weird directives, and I mean, come on, you need to wrap things in do-while loops. It was kind of really weird. So we were like, how to like avoid this thing that kind of looks like a nightmare? And we were lucky enough to see that there is, as you can see underneath, like Node addon API, which is again maintained by the same people that made Node.js. It's having a lot of stars on GitHub, and this is the whole basically abstraction over an API. And this is a go-to tool when people exactly want to do what we wanted to do. Have some methods in C++. You want to have those C++ methods in your Node.js thingy. So, okay, use Node addon API, expose those methods, and live a nice life. And when we looked at these types, they were kind of mapped one-to-one to what we need in TypeScript world. So we were kind of like, oh, this is awesome, this is cool, and it's super supported, and it's made by Node.js team. So like, okay, that's a great library for us. So, a little bit about it. So, basically, node-gyp stands for Node Generator Projects. It's a tool that comes with, it started, they started their development even from the first versions of Node.js. So it's kind of native to Node.js ecosystem. And what essentially it is, it's basically a tool that creates for you a lot of like configuration scripts once you write them, takes these configuration scripts and takes your code that's written in C++ or C and spits out kind of like either makefile or this VCX project thing that's native to Windows. And then from those, runs those in the background and creates this, instead of like a native executable, creates this .node binary. But it's a binary file, but you can treat it as a native dynamic shared library. So like DLL in a way, but a bit, I would say, not smarter, just like more native to the node. And this is something that you could do forever in Node.js since the first version. And so basically, what are the prerequisites if you want, for example, to do the same for Linux operating system? Basically, you just need Python. You need probably to have make installed, and also probably some compiler for C++ code, in this case like GCC. And if I'm not mistaken, Python here is only used to take in the config files that you created and kind of parse that and do some additional things on top of it. So it's kind of initial kind of tool in the whole process of the node-gyp node-gyp GYP tool. And then also for Windows, it's basically the same thing. It's just that you need their Visual Studio build tools. Usually those come if you install the latest Visual Studio IDE. And then you need to also npm config to set this specific version you want to work with. This is the latest one they updated, 2017. But I think 2019 is now in the works, I'm not sure. But yeah, those are just some kind of prerequisite in order to run node-gyp as a tool. And this is these things you need to have in your system only if you're developing a new native add-on in the Node.js. If you're a user, which our customers are, they don't need any of these things. Because our package will ship with this .node binary, or DSL, and node-gyp also has this kind of consume-only option that runs in the background when you npm install it. So once you are developing and once you install these prerequisites here for operating system of your choice, yeah, it's the same for macOS. It's just you need this Xcode build tools, and then you need to install it globally because you're going to develop stuff for using node-gyp. And then run configure in your repository or directory of choice where your code lives. And then node-gyp build, and that's all it will create for you once you have code or rather implementation of your API. It will just create this .node in the release, and you can include it everywhere or export it and create a node package. So how does the code look? So on the configuration side, there is a binding.gyp, which is basically a JSON, and they just smartly called it this, so they know how to target it. And then, of course, package.json, because you're creating probably some node package that you want to include in your other projects. And they're in node-gyp, maybe you don't see it here clearly, but I will read it out. You have targets, and there you just name your library or the target. It's basically your library, how the library will be called. Then you put some C flags. Those are compiler flags because if you allow exceptions that are thrown within the native code, once you compile this DSL, it will show these exceptions as errors. So your code will stop working. It will break. So what you want to do is kind of to ignore these exceptions. So there are two ways. I put both ways here. You can put these C flags, which is native to your chosen compiler, or you can just use the abstract version one, which is you have these defines, and then you have a constant that you passed, and here I passed an API disabled CPP exceptions. So it's it will ignore exceptions. It will show them, but it won't break your code. It's just some kind of thing because they also have this purity thing around them. And besides that, yeah, you need your sources, and sources are kind of important here. Each source is when it comes to an API, is split in two. One is your index CPP, or call it whatever, but just something different than your actual library name. And this is the wrapper thing, where you wrap or rather you can think of it as a translation layer, where you kind of wrap your C++ implementation or C++ methods into some kind of a specific Node API things, and that will expose it later. It will know how to translate that to your Node.js code. So that's when it comes to sources. And so those are the bindings, yeah. And then on the package.json side, just standard package.json. It's only the difference that you have from your standard package.json when you're defining your own package is that in the scripts part where you run npm install, you exactly run the node-gyp rebuild command. And this is the thing that I mentioned that is used for users, for consuming. Because you could also put their build. It won't change much, but it won't like create. It won't like reflect on artifacts that are created during the build time, because you want to just build the diff basically of what changed. So especially when you bump the versions. So usually you would like best practices to put rebuild there. So so that's kind of a thing basically that users will then just like go to the node, go to your like node, fetch your library, go to the node packages and check like, oh, there's a .node DSL. Okay, I know what this is because your Node.js knows it, and it will just kind of check and build it. So there's the configuration side. Now the C++ side. There are like 3 files. As a clean C++ practice, there's a .h file that defines your basically API, and here I gave an example of get size. I'm really sorry that you don't see it clearly here, but I'll try to read it out. And then there's an implementation part, which is your CPP file, and then the wrapper here. And as you can see, like in the H file, I'm expecting some kind of std vector to return, and this vector is of some unsigned integer values. And then I get window size and pass as an input, I'm searching for the input window title, and that's a std string, just because it was easier than to use characters. Then in CPP part, I basically just write the whole implementation. There are some just checks here. If you see those ifs there, maybe those are just basically checks to see like if because I'm getting the Windows size and for the input title, which is any string. So first I'm checking like if this window exists. That's kind of first if, or either second. The first one is if the window is in the foreground process, because because for our use case, I wanted to take the size of whatever the user is interacting with. So I take the foreground process. What is really interesting, the same Windows UI automation API also allows you, for example, to bring some of the opened windows to the foreground process without any users like input if they want it or not. So it's kind of really weird. It feels like somebody's controlling your computer if you want to do that. Then also like inside we check if the window is of course visible, because sometimes Windows can have these weird things where maybe you experienced it many times, where you like set some window to the foreground process, but you're still dragging other window from, for example, other screen, and this one will still contain as a foreground process, thinking that it's in a foreground process, but the other one will obscure it. So then this would like return false, for example, in those cases. So we need to take account in those, also those things. And we also like define here one rect structure, and all these like data structures, they are like native Windows data structures, and usually how you recognize them, because they are all caps, always, since the 90s. And this is the thing, because like these data structures are super unique to Windows. For example, for our case, that was perfect because the customer was using only Windows. So like they have specific methods and specific Windows types. So for example, you have Windows 32-bit integer type for some reason. So you usually need to do a lot of conversion or casting in your code. So that's why we kind of have weird like initialization of the variables here. So inside the last kind of branching, there we have like width and height calculation, which is basically once we put the whole window in this rect structure, we kind of try to just calculate like. And the rect structure also has, like in your browser, rect structure or bounding rectangle. It has also like right, left, bottom, top. So we need to just calculate that, push it to the vector, return the vector, job is done. That's super nice. So now if you would like create, for example, some main CPP file and just run this method, it will return like for any input window name, like whatever the name of the window is, it will return your size as a vector of that has two values inside. And then the wrapper or the binding thing is there on the right hand side, where we, as you can see now, the code starts looking more like kind of JS code, but still kind of is wrapped in a lot of C++ weirdness. We have this NAPI or NAPI kind of namespaces. This is like every single method, because JavaScript wrote everything is an object. So every single method is basically treated there as an object. So you write like an API object, then your function name that you want to use, and then as an input there you take this kind of info thing. It's called callback info. Honestly, don't know why that's the name, but what it essentially is whatever input you pass here, how many parameters you pass here, because parameter can also be a callback, so I assume that's the also thing, input parameter to the method. So what they do basically is like, if you would now pass to this info like 10 parameters, they would just kind of be stored in this array, like super simple, stupid array. And then here we take this environment, because all of this is kind of, when you like write it, you should think of it as a sandbox that kind of is sandbox to your local method environment, just a naming convention within the Node world. And then you basically, I extract from this environment, maybe you can see there's an info, and then in the parentheses like 0, I take the first element from the info, meaning like there's only one argument, and just cast it later to the string, sorry, because I will need a Windows title. And then I create this NAPI array, or sorry, not array, object, because basically what I want to return is width and height in the object form of JavaScript. So I create an empty object that I fill with object set and then just the value. And the result is fetched here from the call, and the call is actual call to this method, the C++ method. The point is that this is nice. You wrap the method, C++ method in Node. Now how to kind of initialize it to the DSL. Basically you have here like exports, and those are run within the object init method, and this is like existing in every binding or wrapper for an API. And you basically just, define like a method name in the string, like as a string, and bind it to the function. As you can see, an API string, and then the second one in the export set is an API function. So basically, what node-gyp, once it compiles it, it takes basically this kind of, treats a function as this kind of exposed object. On the JS side, it's super simple. If you are defining like a node package, you just create in the JS or whatever, main.js, and just export module exports, and then export the required .node DSL, or I will call it binary. Here we call it Palantiri, whatever, but it can be called whatever. And it's built from the node-gyp once you run it. And you expose it there, and for example, this is how you're using it. So for example, I just require the library that's maybe hosted on my private node package repo or whatever, maybe public. And then I just constant size, this is your standard JavaScript code. You can, I pass here, as you can see, like calls, Microsoft Teams. So basically, this is exactly that I'm getting the size of a window that pops up once you start calling somebody. So for example, if you would run this code and there is no call, it would return nothing because it's kind of safe enough. But as soon, for example, if I would set it in some like set interval or whatever, or some mutation observer, it will like just try to find over and over again, like if there's a call string. If it is, it will just get the size console log it, and you can see maybe here like console log it looks like width and height, and for example 800 by 600, and it works. So this is a demo. So we are in the browser now. There's a window in the browser. I focus on the Microsoft Teams in Electron, and there's my pop-up, and it follows, and it repositions even nicely. I don't know which element is locating it now, but yeah, that's an example. And this is, for example, exactly something that our kind of customers needed. So yeah, this is the working example, and it's kind of seamless integration, right, from the browser to whatever. And as I said, the whole web app, the big one that's hosted, communicated through the WebSocket to some kind of background Electron process down there that's running, installed in your, once you like install, let's say our extension, we install also this kind of background thing. And that's how it knows, like, okay, now I switch to some native browser, whatever, and then this node thing that we kind of created, this an API thing that we created, tries to actually position that bubble and then spawn another Electron window. So this is the whole Electron window, this whole bubble thing, or tooltip thing, however you want to call it. So when we were kind of researching this, we were also like thinking, why not use WebAssembly? And we tried to kind of look at kind of pros and cons, and it turns out, in most simple terms, that an API is enterprise friendly, and Wasm is cool kid on the block. Basically, sure, WebAssembly was faster in some cases, but an API is better when it comes to stability. Why is that? It has this ABI, I think it's called abstraction building interface, which is a thing that you have with Node apps, and for example, especially when you're working with Electron, it's basically standard to like stabilize your versioning and your whole Node.js dependency to a particular ecosystem. So you, for example, don't need to care if Node version updates that your old library will work. It will. So that's the API, and an API allows us that. That means whenever they change new version to Node, and for example, we start using Node 38 in the future, whatever, it will work. Our Node package will work. This is not the case with WebAssembly. You would need to recompile it because also now, because like there's frequent changes with WebAssembly, and it's kind of a virtual machine in itself that's running in the node. Plus, it's also single-threaded. Here we could have multi-threading. Best part, that's why I put the second bullet point. It can be more performant in specific cases. Don't forget, writing native assembly x86 assembly code is possible in C or C++ code base. That means that we, even if we wanted to really geek out, we could write our own assembly code, wrap it in a C++, wrap the C++ code in Node.js, and have the fastest solution ever, for example, for giving sizes of the windows if you wanted. This is not the case for WebAssembly. I mean, you could maybe write the actual WebAssembly textual code, but still, I think it would be slower. Only benefit that we found was it works in browsers. And API is reserved only for server side or for your like native applications. You cannot like use these things in the browser. Also, other thing is, let's say you are, for example, doing some kind of network request that's in C++. For whatever reason, you find it more performant to get whatever request through C++. You do this network request through C++, and then you get some kind of request structure, native request structure back. This structure, if you want to move it back to JS for it to swallow, it's kind of super easy and native to an API. In WebAssembly, this is super slow. You would need to even additionally wrap all of the return parameters to whatever, exactly because it doesn't have this node addon API thing that we had that I showed initially, where your all abstractions live, that are one-to-one mapped to, for example, TypeScript, but JavaScript types. And then it's in Node.js since the beginning. It's maintained by the Node.js community, so it's perfect. With WebAssembly, there are more tutorials and guides and blog posts, so like an API cannot win there. Like, it's also like when we started searching, an API looked like super niche thing, like nobody knows what an API is. And when we Googled solutions for WebAssembly, there were like tons of Google results, so it was like, yeah, community is super hyped about WebAssembly. So, what is the future of all this? I just found out maybe like a month ago, there is this Neon thing that's basically, because all the hype is now with the Rust, so there is a thing basically that a library called Neon, or a build tool called Neon that's, I didn't check the implementation, but it's somehow integrating with the Node.js, where you can basically write Rust code and wrap it in Node.js, and it's working. It's also like having API stability and all of these things that I mentioned. So that's kind of a future thing that we might look into it, because especially it's also really way easier to find now Rust engineers than C++ engineers. It's like, just for example, we couldn't wrap this Windows API in Rust because there is no Rust bindings for that, but we could maybe FFI it and still maybe get some solution. But yeah, so this is, I guess, the future of this whole world of building native super fast code, wrapping it in JS and kind of running it natively as a JavaScript code. So when I finished with this, I was suddenly like, wow, this is amazing. Now I can like port every single library of C++ code in JavaScript and map it one-to-one, and then people can just write JavaScript and use C++ world in JavaScript world. So that was really cool. So questions?
Stefan,
Yes.
Try to browse fly.com/webup, and then just read the question aloud, so people know the question.
Sorry, WebUP.
It's like the magnetic tool.
Yeah.
Double O.
Okay. Okay, so I also, how did they cause the concealer? It's super easy. He is originally from Kharkiv, the city that was super bombed, and because he was kind of rich, he immigrated in the first round to Netherlands, and then he was kind of stupid that he was super bragging about his money, and he was like taking photos on Instagram of he and his girlfriend buying a flat in Netherlands and whatnot, and like they were like, okay, this guy, he's 26 years old, but he looks like a kid. They're like, okay, this guy is weird, and somehow they backtracked it to him because he was super exposing online, and then they found him. They also found the camera exactly on the border crossing, like I think he even crossed in Slovakia, so like I think that the shot is... I linked there, by the way, on the presentation, which I can maybe ask Dano and then share later. I have a link like for the whole story where you can read it. But yeah, okay, nice presentation, thank you for that. But the codes you showed were all, yes, so I'm sorry, I didn't know that they were like this super invisible. I can again share this presentation and you can see. I don't have a public Git repo because this was all done within the company's policies, but maybe it's a good time for me to create it, but also I can point you to good documentation where you can find this thing. Can this technique? Yes, it can work. It's just that you need Xcode instead of Microsoft Build Tools. Initially, we didn't try it, but for example, some blog posts that we were kind of learning from were using macOS. How about Linux Unix-based system? It's the same I showed there. It's just that instead of Windows Automation UI library, you would need to use X11. Depending. But if the problem gets harder, there's maybe an option of using Selenium, but I'm not sure it would work because we tried that. How much? Double the speed, but not in the Windows API thingy that I was showing. It was slower, double the speed, for example, for calculating Fibonacci sequence. But if you would do this for like these native calls, I think you wouldn't get the double speed. Is the wrapper auto-generated? No. You write everything here. The only thing that's auto-generated is this .node, I'll call it binary, but it's dynamic shared library. That's the only thing that's auto-generated, and that's the only thing that kind of knows how to map this, but you need to show it by this index file and other stuff. How about, okay, that's la 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 la. Do you need someone to dispose API objects to prevent memory leaks? Good question. You memory manage inside the C++ code, not in wrappers. That's all I can say. I don't know internally how they deal with these objects exactly that I showed. I think that's just some kind of translation layer. Memory management is done in the C++ implementation.
Stefan, I guess like this question definitely deserves a T-shirt.
All questions deserve a T-shirt, so I will need to later. How does configuration code of onboarding helper look like? Do you need to cover? Do you need to cover all user journeys manually? It's some of that. For now, all manually, because it's not that we configure. Sometimes they have their admins and they're like, "Oh, we know how to make these guides," but this kind of adaptive generating of the guides, that's work in progress. Might be off topic. Is it necessary to use AI to see if your user got stuck in a border? Yeah, this question is super kind of general, I would say, like what is AI useful for? But in our case, it showed in the kind of experiments our AI team did that it is, especially for like the previous question, like generating what's or predicting what kind of user might click next. Therefore, like saying like, hey, you kind of created this guy to click to show like point to X button here, but it's actually people minimize this, for example. Upscale code, yeah, I will, sorry, I didn't know about the venue and stuff. It's applicable to anything, and this is amazing because Windows Automation UI, that is the API that's actually used for accessibility features in Windows. So all blind, disabled people can actually use Windows normally. How? Because of this API. And hence, that's why it's available without any permissions, which is kind of weird because once I find it out about it, I was super afraid. Like, one misclick, malware inside, I can do anything. You can read from the form inputs, even though the input is obscured, for example, for entering passwords. Because Electron, what it actually does, it also exposes these like native HTML components to actually native components in your Windows. So like your document.button or whatever add element button or div is actually called panel on the Windows. And there's a really nice tool actually where you can like inspect this and see like how this translates to your native Windows. Can an antivirus program interfere? This all depends on the policies of your machines. We have customers, and this I didn't know can even be possible with Windows specifically. But you can have Windows locked so much that, for example, you cannot even have a right-click option on your desktop. So, sure, if you have like policy set up by your administrator to the Windows that they even block your accessibility options, which is usually not the case lately in the big enterprises because of the whole diversity and inclusion thing. So, we didn't have that case. And since, because this was running inside Electron, since they are making a contract with us, they allow our Electron app, and our Electron app is running all of this code. How to disable the accessibility features? Done. Okay, any more questions? If not, I will just point to kind of a marketing thing.
I did not understand. Sorry, how do you disable this?
Disable the accessibility Windows features.
So you mean it will be not accessible at all?
Yeah.
Okay.
But
no, accessibility features are it's just the name accessibility feature. It's like these features for like screen reader.
for disabled people.
For disabled people.
Okay.
There's I can maybe find it, but it's like there somewhere in the settings. Sorry, just the last slide is. Okay. So thank you. This is our website for hiring careers. We are looking for senior software engineers. If you really like what you see and want to do this cool stuff like Mark did, maybe not buy a flat in Amsterdam, but still earn a lot. You can like come and work as a software engineer with AppLearn. We are really in need for engineers because we are really growing fast. The company is now 200 people. There's 30-something developers, and we want to double as soon as possible. So come join us. There's a small thing that you don't see here. Maybe if I shrink it. You won't see it. If you want to get in touch with me personally, I usually blog on my own blog called whitetower.info, so it's easy to remember. You can reach me out there. I have all of the social networks. So.
Stefan, I will share it with people.
Okay. So thank you very much for your patience, and it was great. So first, before I leave, I have some t-shirts. So please, people that ask questions, but also the others come for t-shirts. I have 10 t-shirts here. I have 4 XLs. So first XL t-shirts. XL size, somebody. Come on, don't be afraid. Okay.
Give me one.
Yes.
Thank you.
No. Thank you. Okay. One more XL. 3 L t-shirts. Anyone? Okay. L. Somebody more L?
None, but for me.
And now for girlfriends, fiancés, and wives, M t-shirts, 3 M t-shirts. Okay, 3.
He's skinny.
One is back there, in the back, in the very back.
Okay, thank you for coming.
Stefan, thanks a lot.